Next, let's continue with example 6 on page 853, where we have sine cubed 2x, and we're supposed to prove that equals to that stuff on the other side. So let's go ahead and do this. The first line is, let me write this down, okay? The first thing we're going to write down is sine cubed of x is equal to sine 2x times sine squared of 2x. Okay, remember the 2 here means this thing, the whole thing is being squared, but we only write it over there. And the same as here, okay, the cube power means the whole thing, sine of x is being cubed, raised to the third power. So we got here, so far so good, okay? So next, what are we going to do? Next, we are going to follow the formula of sine, that is this one. Let me pull out the formulas we're going to do. And we're going to follow the one where it says sine squared equals to 1 minus cosine 2 theta. And the one right here, okay? And see, sine squared theta is equal to 1 minus cosine 2 theta over 2. And we are going to set theta equals to 2x. So this will be the theta right here. So if theta equals to 2x, following this formula, then sine squared 2x, this part, just this part, okay? Sine squared 2x will be 1 minus cosine of 2 theta. Theta is 2x, so 2 theta will be 4x, right? I'm still following this formula right here. Let me make it as big as possible. Yeah, so you can see it like that, okay? So then theta is 2x following this formula right here. Then sine squared theta will be 1 minus cosine of 2 theta. That's 4x divided by 2. So that is just this part right here. I'm following the formula, right? So I got to, so this thing can be replaced with that thing. All right. So next, what are we going to do? Oh no, I lost my page. Okay. I got it back. Good. And I lost it there. Okay. And so that is the next one. And then after that we will have so this whole thing equals to that times that. All right. And then the next part is the next part is, this is it. That's what we're trying to, that's the other side of the equation, okay? Because the problem says that we need it to be 1/2, okay, that's the half, sine 2x, okay? And then 1 minus cosine 4x, so we're done. That is example 6. All right, so that is, so next, we're gonna, please turn to the next page, page 854, and let's look at the half angle formulas. Okay, now let me write that down. So on page 854, we're going to derive a form at the very top of the page. You might see something like this. Okay, the sine. We're going to derive this formula. That is, if alpha is an angle, then sine alpha over 2 equals to this formula right here, equals to the square root of 1 minus cosine alpha over 2. Now, how are we going to derive that? We're going to start with the sine squared theta equal to 1 minus cosine 2 theta over 2, which is the thing that we just saw. Okay, but I will show it to you again. This thing right here. I'll make it a little smaller, doesn't need to be that big. Okay, see? That is, we're going to use the reduction formula for sine squared theta, which equals 1 minus cosine 2 theta over 2. And we'll quote that over here. Now, starting with sine squared theta, and we are going to, in this case, we're going to let theta equal to alpha over 2. So we'll plug in theta wherever there's theta, we'll substitute it with alpha over 2. So we're following that rule. Then plugging in alpha over 2 in where theta is here, that 2 theta will be just alpha, okay? Because 1 theta is alpha over 2. So 2 theta is just alpha. So then the formula becomes sine squared alpha over 2, which is theta here, becomes this thing 1 minus cosine alpha over 2. In that case, then, that means that if we take the square root of both sides, then sine alpha over 2 will be equal to the square root of this stuff. With the plus or minus sign in front, that means there are two possible answers. It could be the plus 1 or the minus 1. Instead of writing two things, we just write it to those two equations into, put the two equations into one, which is why there's a plus or minus sign over there. So that's how the sine half angle formula is formed. And next, let's look at the cosine half angle. The cosine half angle is formed in a similar manner. First, we will use the cosine formula, which says cosine squared theta equals to, and that's not the same one. Well, I don't care. The point is there's the cosine squared formula equals to that, and that comes from, yeah, that's the second one of the reduction formulas, okay? This is, I just got this from this section, a few pages before, okay? And in the reduction formulas, but anyway, so cosine squared equals to this thing, so we'll write this thing down right here. Let's write it down and go from there. Okay, so that's repeated right here. And again, we let theta equals to alpha over 2. Then 2 theta will be just equal to alpha. Okay, so then we plug that in. So this thing, cosine squared alpha over 2, then equals to 1 plus cosine of alpha, because that's 2 theta got turned into alpha over 2. And that's it. Then we just take the square root of both sides. And again, so then we got the half angle formula for cosine. Cosine alpha over 2 equal to this stuff right here. So that's the cosine version. And so next we'll do the tangent version. Now the tangent version, it comes from the original reduction formula for the tangent one. Let's see. See, the reduction formula states that tangent squared equals 1 minus cosine 2 theta and over 1 plus cosine 2 theta. So we'll write that down as let's see where to go. Okay, so and plus or minus right here. Got it. All right. So we write down the tangent squared, which is this thing that we just saw, and then we pull the same trick. We let theta equals to alpha over 2, and then plug it in. So 2 theta is just alpha, see? So then it becomes 2 theta got turned into alpha up on top and on bottom, right there. And then as a result, we will have, therefore, that's tangent squared. So tangent will be taking the square root of this thing for the plus or minus value. So that is the tangent alpha's half angle formula. So continue looking down a little bit. There's the summary. We have, this is the stuff that we just proved. Okay, sine alpha formula, sine alpha over 2 formula. Oh, these are the half angle formulas. Cosine alpha 2 and tangent over 2. However, it also says something like this. Okay, towards the bottom, it says something here that the book did not bother proving. And I suspect that maybe they forgot about it and added in later, so there's no space to prove it. Okay, so, which is okay because I dug it out. I dug out the proof somewhere, so we're going to prove this thing. Both of these formulas, that is tangent alpha over 2 equals to that, but it also equal to this and also equal to this. And when you pick one, pick the one that's most useful for you at the moment. So let's prove those two things. So I got the proof of the tangent half angle formula online. I just asked the AI, and this is what it says. So I want to show it to you. Now to prove that tangent alpha equals to 2 equal to sine alpha over 1 plus cosine alpha, we use these two formulas that we learned in this section, in fact. Okay, first, sine 2 theta is 2 sine theta cosine theta, and second, cosine 2 theta is 2 cosine squared theta minus 1. Now, that is something that we saw not that long ago, right? In the same section, I have summarized right here. Let me make it a little bigger. Here we go. So see, sine 2 theta is 2 sine theta cosine theta, and cosine 2 theta has 3 versions. One of them is 2 cosine squared theta minus 1. Is that what we were talking about? Yep, it is. Okay, that's exactly the one we're going to use for this proof. So let's do that. So here is our proof. Okay, the let's see, let me hold on to this thing. Okay, so cosine 2 theta equals to, we choose the one that says 2 cosine squared theta minus 1, because these two will come in handy in proving this equation. And to use these things, we're going to use theta equals to alpha minus 2. Okay, and then substitute in here. So the first one's, this is then, if theta is alpha over 2, then 2 theta will be just alpha, okay, which is sine alpha, which equal to 2 sine theta, which is alpha over 2, cosine of theta, which is alpha over 2. Okay, that's numerator is equal to the numerator here. Next, 1 plus cosine alpha, alpha is equal to 2 theta, right? And then so 2 theta becomes alpha, and over here is let's see, the original 1 plus, give me a second here. What was I doing? So next, we'll do the 1 plus cosine alpha. I should say that we're starting the proof on this side. Okay, we're starting this thing, and we're going to work our way down until to show that this thing is equal to tangent alpha. So we're starting on the right-hand side and proving our way to the left-hand side. Okay, so continuing, 1 plus cosine alpha, alpha equals to 2 theta from this equation here. So then using this equation, so that will be 1 plus cosine alpha is cosine 2 theta, which is 2 cosine squared. Okay, theta is replaced with alpha over 2 minus 1. So next, now having seen that, so next what we're going to do is just simplify. There's a 1, there's a minus 1 there, so we'll get rid of those, and we got here. Next, we have 2 and 2, we cancel that out. We have cosine squared alpha over 2 and cosine alpha over 2, so we cancel that out. What we have left is just sine alpha over 2 over cosine alpha over 2, which is exactly tangent alpha over 2. And tangent alpha over 2 is exactly what we were trying to prove before. That is, we started on this side, okay, and worked our way over to here. And that's that is the end of the proof of the half angle formula. All right, so far so good. The next thing we're going to do is prove the other version. There are 2 of them. Okay, first is tangent alpha equal to this thing that we just proved, but there's another one, is that it also equals to this. So the tangent alpha over 2, the tangent half angle formula has like 3 options to pick from. So to prove this is the method is identical to this one, but we're gonna start differently. That is, in the previous proof that we just did, we started at the right-hand side. That is, we started here and worked our way back here. Now this one, we're gonna do it differently because that's what the AI did, okay, when I asked it. It decided to start on this side and work towards that goal, which is fine. And so we're gonna do something very similar except backwards, okay? We're gonna go back from the bottom. But otherwise, we'll go through very similar steps. First, the definition of tangent alpha over 2 is sine alpha over 2 over cosine alpha over 2. So the next step, we're going to multiply this 2 sine alpha over 2 top and bottom for no reason at all. Why? Because previously, over here, we canceled out a 2 cosine alpha over 2, right? So we're going to simulate that process. So we're going to multiply it back for no reason. But this time, we're going to multiply by sine because for important reasons, okay? That's the only way it's going to work. So once we multiply it, what's going to happen? Okay, this is a trick. In math, we often pull off tricks, neat little tricks that make things happen. It's kind of like magic, in fact. So with the magical sine alpha over 2 times it, and both on top and bottom, we end up with 2 sine squared on top, okay, and then 2 sine cosine on the bottom. What is so next we are going to follow these two formulas under it. Now so 2 sine theta cosine theta is equal to sine 2 theta, right? So this thing is equal to sine of 2 times alpha over 2, which is sine of alpha. That's the bottom. Now on top, 2 sine squared alpha over 2, following this formula here, is right here, okay, except that's a minus. So if we move this over here and then move the cosine over there, then it becomes this thing then equals to 1 minus cosine of alpha, being that alpha equals to 2 theta. Okay, we're using theta is alpha over 2, so 2 theta equals to alpha. So plugging the 2 theta in here to be alpha, we get 1 minus cosine alpha, and that is what we're trying to prove, because in the beginning, that's identical thing. That's exactly what we're trying to prove there. Okay, and that is the conclusion of proof of tangent alpha over 2 with those 2 extra formulas that the book did not get around to proving. Yeah, they probably ran out of space, which is probably why anyway, but that's fine, right? And nothing, no harm done. So I found the proof for it, and it all looks very nice. So as you notice, the trick here is, well, in the first case, the way to prove it is just find the right formulas to plug it in with. The second case is using a sort of a random trick. Is that's the kind of stuff. How do you think of such a trick? Well, you just kind of, well, you throw stuff at it and see what sticks, kind of a thing. Okay, that is how some of the math is proved. And having said that, let's get back to the next thing what we're going to do, which is example 7. So next, let's do let's do example 7 on the same page, where we're supposed to calculate sine 15 degrees by using the half angle formula. What that means is we're going to do sine the hard way. This is old-fashioned, but okay, I guess. So sine 15 degrees, okay, that would be sine of 30 degrees divided by 2. All right, and then we're going to slap on the half angle formula. What is sine alpha over 2? If alpha is, so let alpha equals to 30 degrees. So sine of alpha over 2 is equal to plus or minus. We'll just keep the plus, because sine 15 degrees is positive, so we don't need to worry about the minus. So keeping the plus, this is equal to 1 minus cosine of alpha, alpha being 30 degrees, and then over 2. That's that's that. And so the next job, we need to figure out what is cosine 30 degrees. Now sine 30 degrees, well, we don't care what sine 30 degrees is. We need to figure out cosine 30 degrees. We looked at our handy little triangle here. Cosine of 30 is square root of 3 over 2, okay, adjacent over hypotenuse. So then that equals to, write down this thing, 1 minus square root of 3 divided by 2, and then divided by 2. And that's basically the answer. However, we might want to, let's see, do we want to simplify this or anything? What does the book want? Let's see, square root of 3 over 2 over 2, right? Yeah. I suppose we can simplify it a little bit. So this simplifies into, if we work with radicals, and please refer to the first chapter of algebra if you don't remember how to work radicals. So that equal to, first we'll do what's inside. So this becomes 2 minus square root of 3 over the whole thing over 2. Okay, we have the common denominator trick here, and then divided by 2 again. So the whole thing is dividing by 4. So we can take the 4 out, which becomes 2 here, and then this becomes 2 minus square root of 3. Now notice that this 2 is out of the radical sign, okay? And this radical sign covers the whole thing. You divide by 2 and divide by 2 again. It's the same as dividing by 4, and we can take it out of the radical sign. It becomes 2, and that's how this answer comes from. This kind of problem is not that interesting nowadays. Back in the day, this is useful because in those good old days we didn't have the calculator. So to calculate sine 15 degrees, this will give its exact value. Okay, so you don't have to write down some decimal point. But nowadays we can do that with punching as fast as you can do punching the calculator. So it's not that big of a deal. But we did it, so that's okay. All right. So next, let's look on the next page, example 8. So next, let's look at example 8. The example 8, I would like you to do this yourself because it's a rather tedious but straightforward way of calculating the half angles from the original formula. The only thing I want you to pay attention to is the alpha is supposed to be in quadrant 3. That's the one down here. The quadrant counts 1, 2, 3, and 4. So then if it's in quadrant 3, and when you calculate alpha, the half angle will be in quadrant 2. Okay, so then you have to watch out. In quadrant 2, the y value is positive, so the sine is positive, but the cosine is negative, and then the tangent is also negative. And that's the only part that you have to watch out for. Otherwise, please do example 8 yourself, okay? And the book gives a detailed explanation of how it's done if you need any help. So that's example 8. And next, let's look at example 9. Okay, so next let's look at page 857, the last example, example 9. Well, example 9 says that we have some bicycle ramp, and it has some angle, okay? And the tangent of the angle theta is 5/3. The question is, how much is half of that angle? Well, that's easy enough, okay? It's because the tangent of theta is 5/3. It says so, right? So to figure out what the angle is, yeah, my calculator happens to be on degrees, so we're good. So let's calculate inverse tangent of let's see, I don't need that many parentheses. Inverse tangent of 5/3. That will give the angle of the ramp, okay, the angle of elevation. And then it says what is half that much? Then let's divide it by 2, and that's 29.5152 degrees, which is let's check with the book, and that is yep, it has 29.7, close enough. My answer is perfect, okay, because the book's answer is just an approximation after cranking out all that stuff, so it's losing some accuracy. So anyway, that is the answer to example 9. Example 9 wants you to do the tangent half angle, but we're so not doing that. Ugh. Why are we going through that much work when they just want the half of the angle, you know? So let's find the angle and divide it by half and call it done. So that is that. Now for homework of this section, please do all the examples carefully. And the way I show you to do it, and then on page, this is 858, the homework. Please do problems 7, 11, 21, 25, 27, 29, 33, 35, 37, 41, 43, 43. Sorry, 40. What, I wrote 43 twice. Okay, and next 51, 55, 6, 7, 8, 9, 10, and 61. Okay, and the last problems are all done in a row because those are all proving identities, and those are probably one of the most important parts of trigonometry is knowing how to prove identities. That's going to be used quite a bit after trigonometry. So please give yourself extra time to do that. I know that sounds like a lot of homework, and it is, but they're worth doing, okay? And not every homework is worth doing, but this one definitely is. That you should have a good enough as good a grasp of proving trigonometric identities as you can. And I will go over the homework in the next section. So please go do your homework, and then I will explain it in the next video.